So it's the product rule and quotient rule. Yeah. Right. So product, right? Two functions multiplied together. Makes sense, right? Quotient, two functions divided by one another. So for the product rule, consider two differentiable functions. F of x and g of x. Then the product rule is, you have f times g prime is equal to f prime times g plus f times g prime. So this is the product rule, right? So you have to identify what is the function f, what is the function g, right? Just multiply together and take the derivative. The derivative of the product is equal to f prime times g plus f times g prime. That's it, right? All right, so let's practice this particular rule. So differentiate following function. You have y equal to x cubed plus 2x times e to the x, right? Another notations that I normally use to distinguish between f and g, I'm usually use u and v, right? So the product rule can be also written as u prime times v plus u times v prime, right? So it's easier to spot, right? You don't get confused with the function f and the function g. Right, so let's identify u and v, right? So this part is u, and this e to the x is v, right? So you have two functions multiplied together. The first function is x cubed plus 2x. The second function is e to the x. So if you want to take the derivative of this, that means you take the derivative of the first functions, multiply with the second, plus the first function multiplied with the derivative of the second function. And the first functions we just identify is x cubed plus 2x, and the second function is e to the x, right? So I'm going to write the first function prime. So x cubed plus 2x prime times e to the x plus x cubed plus 2x times the derivative of e to the x. Right. Right, so the derivative of the first term right here is equal to 3x plus 2 times e to the x plus x cubed plus 2x times e to the x, because the derivative of e to the x is just e to the x. Right, so the second example, I'm going to write f of x is equal to square root of x times also e to the x. Let's see what we got here. Right, so once again, let's identify two functions u and v. So this is u, this is v. When you take the derivative of this function, you get the derivative of the square root of x times e to the x plus the square root of x times the derivative of e to the x. So the derivative of square root of x is easier to turn square root of x into a power function, right? Turn that into x to the 1/2. Right? So it's going to be a lot easier to differentiate. Right. So derivative of x to the 1/2 is 1/2 times x to the negative 1/2 times e to the x plus square root of x times e to the x. Right. And if you want, you can turn the first term 1/2 e times x to the negative 1/2 to the positive exponent. Right. So you do 1/2 times 1 over x to the 1/2 times e to the x plus square root of x plus e to the times e to the x, all right? Now move on to the next function. Have g of x equal to x cubed minus 2x squared plus 3 times 7x squared minus 4x. Right. Once again, when you look at this type of functions, let's identify u and v. So the first function here is u, and the second function, 7x squared minus 4x, is v. And you want to find the derivative of this function. And you get right, derivative of the first function. Sorry, this is 2x squared. This is 2x squared. Sorry. I'll take the derivative of that times 7x squared minus 4x plus x cubed minus 2x squared plus 3 times 7x squared minus 4x prime. So let's take the derivative of the first functions. So the derivative of the first function is 3x squared minus 4x, right? And that's it, times 7x squared minus 4x plus x cubed minus 2x squared plus 3. Take the derivative of the second function, which is 14x minus 4. And then that's it for the product rule, isn't it? It's just some more example. D, you have the function f of x times 2 to the x equal to 2 to the x times e to the x. Right. So the first function is u. So u is equal to 2 to the x, and v is equal to e to the x. Right. So the derivative is 2 to the x prime times e to the x plus 2 to the x times e to the x prime. And this is the exponential function. We know that the derivative of 2 to the x should be ln of 2 times 2 to the x, and then times e to the x. Now for the second term, you have 2 to the x times the derivative of e to the x, which is just e to the x. All right, so I'm going to move on to the next rule, which is the quotient rule. So also consider two differentiable functions. F and g. Then the quotient rule is of differentiation is differentiation. U divided by v prime equal to u prime times v minus u times v prime altogether divided by v squared. Okay, now let's work on some example right here. So because we talking about two differentiable functions, so f and g, so I'm going to write the function in terms of f and g as well. It's going to be very similar to the case of u and v. So f prime times g minus f times g prime altogether divided by g squared. Assume that in this case the denominator is different from 0, of course. So example. So differentiate the following functions. Let's say part A, f of x equal to x squared plus x minus 2 divided by x plus 3. All right. So just like the product rule, try to identify what is the u function, what is the v function, right? So this is the quotient. What you can do is you can write this as, so this is u and this is v, and then you can apply the quotient rule of differentiations. Right, so derivative of this is u prime times v minus u times v prime altogether divided by v squared. Right, for u is equal to x squared plus x minus 2, and v is equal to x plus 3. Right? So this give me, so this is x squared plus x minus 2 prime times x plus 3 minus x squared plus x minus 2 times x plus 3 prime, all together divided by x plus 3 squared. Now, can you differentiate term by term here? So the derivative of x squared plus x minus 2 should give me 2x plus 1 times x plus 3 minus x squared plus x minus 2. Derivative of x is 1, derivative of 3 is 0. So I have 1 here, all together divided by x plus 3 squared. Now the functions that we can look at is, let's say g of x is equal to e to the x divided by 1 plus x squared, right? So you can identify this as u over v, right? Because that's the quotients for u is equal to e to the x and v is equal to 1 plus x squared. Now you take the derivative of this, and what do you get here? The derivative of this is u prime times v minus u times v prime all together divided by v squared. Right? For u is e to the x and v is 1 plus x squared. So you get e to the x prime times v minus u, which is e to the x, times the derivative of v all together. Have 1 plus x squared, then square. Right. So you continue taking derivative, you have e to the x times v in this case is 1 plus x squared minus e to the x times the derivative of 1 plus x squared, which is 2x. Altogether, this is 1 plus x squared squared. Okay, so sorry about this. So this should be, it shouldn't be v, but instead is 1 plus x squared. Let me use another color here. So this is 1 plus x squared. Yes. All right, so I want to give you a note here. So it's not necessary for to apply quotient rule anytime you see a quotient. There's other way to do that as well. So I want to put that in here. So it is not necessary to apply quotient rule anytime you see a quotient. So what do I mean by that? Example, differentiate the following functions. I have f of x equal to 1 minus x cubed over x squared. So I claim that it's not necessary for you to take the quotient rule anytime you see a quotient. You may, you don't have to all the time, right? So what I can do from here is, I see this is a big fractions. I can separate them into smaller fractions. So what do I mean by that? So I can rewrite these fractions as 1 over x squared minus x cubed over x squared. Any questions here, right? Because they have the same denominator. So that's how, that's why I can do that. All right. So because you want to take the derivative, try to change them into power functions, right? So 1 over x squared can be written as x to the negative 2, and x cubed over x squared can be simplified into x, so minus x. Now you want to take the derivative, right? This should be x to negative 2 minus x prime. This should give me negative 2 times x to negative 3 minus 1. Let's try another one. Let's use something else beside the quotient rule, right? So let's say if we can do something like this, where g of x is equal to e to the x divided by x, right? So this is the quotient, right? u is equal to e to the x and v is equal to x. But it's not necessary for you to use the quotient rule here. You can turn this into a product and you will use the product rule. For instance, I can change this into e to the x times x to the -1. And I identified this as e to the x as u and x to the -1 as v. And I say that I can use product rule to differentiate this. Right? You can use quotient rule, it's up to you. I just want to introduce to you that there are other ways to approach a problem. Right? So you can use quotient rule, you can also rewrite the function, so you can use product rule. Right? So for product rule, you have u prime times v plus u times v prime. Right? Or this is e to the x prime times x to the -1 plus e to the x times x to the -1 prime. So derivative of e to the x is e to the x times x to the -1 plus e to the x times -1 times x to the -2. I simplify this, or we write this in terms of positive exponent. You have e to the x divided by x minus, because you have a -1 there, minus e to the x divided by x squared. For this exercise, you can use any rule that you like. It's up to you. It's up to you. So differentiate the following functions. You have part A, f of t is equal to 1 plus 2t divided by 3 minus 4t. Okay. And so I want to use this to do this using the quotient rule. Right, so I have this is u over v, for u is equal to 1 plus 2t and v is equal to 3 minus 4t. Right, so f prime of t is u prime times v minus u times v prime divided by v squared. Well, this should give me 1 plus 2t prime times 3 minus 4t minus 1 plus 2t times 3 minus 4t prime. And v squared is 3 minus 4t squared. All right, so take the derivative of this. I have 2 times 3 minus 4t minus 1 plus 2t times -4. Right, so when you take the derivative of this term, 3 minus 4t, the derivative of 3 is 0, and the derivative of -4t is -4. So let's simplify the numerator and see what we get. So we get 6 minus 8t, -8t, plus 4 times 1 plus 2t, 3 minus 4t squared, 6 minus 8t, plus 4 plus 8t, divided by 3 minus 4t squared. So -t and -8t and +8t cancel out, and you're left with 10 divided by 3 minus 4t squared. Next problem. So f of x is equal to square root of x divided by x minus 1. Right, so this is also a quotient. Right, so you can apply quotient rule. Right. You identify the two functions, u and v. So u is the numerator and v is the denominator. Right, u is equal to square root of x and v is equal to x minus 1. So f prime is u prime times v minus u times v prime all together divided by v squared. And this should give me square root of x prime times v, which is x minus 1, minus u, which is square root of x, times v prime, which is x minus 1 prime, all together divided by x minus 1 square. Right, so derivative of square root of x, we did a similar problem like this earlier. so square root of x. You can turn that into power functions, right? And this should give me 1/2 times x to the negative 1/2. Right, so I'll put this into our problem. I have 1/2 times x to the negative 1/2 for the derivative of square root of x times x minus 1 minus square root of x times derivative of x is 1, derivative of negative 1 is 0. So it should give me 1. Everything is over x minus 1 squared. Okay, so let me give you another one to do here. I have f of t is equal to t to the 4th minus 2t plus square root of t minus 3 divided by t. We see some similar problem like this earlier. It's not necessary for you to use the quotient rule. You can turn this into multiple fractions and you can take derivative term by term. Right, so what do I mean by that? Right, so this is the big fractions. I can rewrite this as t to the 4 divided by t minus 2t over t plus square root of t over t minus 3 over t. And if I simplify this, I get t cubed minus 2 plus 1 over square root of t minus 3 over t. I turn everything into power functions because that is easier for you to take derivative. Right, so I can write t cubed minus 2 plus t to the negative 1/2 minus 3 times t to the negative 1. When you take the derivative of t cubed is 3t squared. Derivative of negative 2 is 0. Right, so I'm not going to write 0. Derivative of t to the negative 1/2 should be negative 1/2 times t to the negative 1/2 minus 1. And minus 3 times negative 1 times t to the negative 1 minus 1. Simplify this, we got 3t squared minus 1/2 times t to the negative 3/2 plus 3 times t to the negative 2. And then that's it. Right, that's it.